what we have here is a failure to communicate. So this is the SV-ROS botback, and I've been doing some enhancements to it. So one of the enhancements is I've added intensity to the laser scan. So right now you see there's the charging station. You see the charging station is really bright green. Well, actually it's blue. And it's a little confused. It's also seeing a fiducial marker. Seeing the fiducial marker. And for some reason, it's getting, let's see.
So is that merging the LiDAR and the camera?
It's trying to figure out the geometry.
Does it need to be plugged?
The problem is when it gets confused because the first marker it sees, it's decided that marker never moves, and I've been moving it around, so the program can't really handle that. But it's seeing that that object is really bright. You see the yellow and blue. And I'll get really confused if I take the fiducial marker away. It doesn't believe that you can move the fiducial marker, so it'll stay there until I clear that map. But so it's seeing this as a really intensely bright object. If I turned it around, the colors get a lot dimmer. So I've added that, and I don't know, Ralph, did you push the intensity change?
No, we'll talk about that, but I'll get that done.
Okay, well, it's one line of code that's changed. So basically, on the botback, they have it's not a LiDAR, it's an LDS, laser data sensor. What? Come on, it's LDS. It's a laser.
Shows a radar image and it does it with the light.
Yes.
Go ahead.
Well, LiDAR stands for rain. Well, okay. Anyway, so basically what you're getting is you're getting the angle, the range, and the intensity of the reflection. We weren't looking at the intensity at all. However, NITO uses the intensity on their charging station. They have retroreflective tape in there to locate the charging station. And I'm not exactly sure, but actually I think they actually get some kind of barcode so they can identify the charging station. So it's just like a regular barcode.
If you look at the pattern of the retroreflective material in there, it's like dot, dot, dash.
Yeah. So it actually is gives a reflection.
Two small strips along.
But I tried it with just some retroreflective tape, and it does. The intensity is like 2 to 3 times of what a piece of black or white paper is. Yeah.
Yeah. Velodyne on their current LiDARs, they will detect retroreflective if you have more than 100% return relative to a sheet of 99% white paper.
Yeah.
Yeah.
And actually, it's at least at 1 meter, it's twice as bright as white paper.
Yeah.
But the thing is, for object detection, you have to write the equation to calculate for the range if we wanted to use, and the goal is to use it to detect an object. In this case, for the Floorbot challenge. The other thing that's working is the camera's working too now. And we could use any OpenCV as far as the camera goes. What I'm using the camera right now for is the Ubiquiti. And actually, let me get the camera there. See what it looks like in the camera. is seeing the marker there, and then and also seeing the orientation of the marker. Now, yeah. So what happened when it disappears, it thinks that maybe the marker's facing in the opposite direction. Hey, it's a Raspberry Pi, it's not a supercomputer. But anyway, so those are, so the idea for people who have the Nito bot back, you can use those extensions for other things. So, and this is the beauty of ROS, right? I'm using the fiducial code and the RaspiCam node that was produced by Ubiquity Robotics on the Raspberry Pi with the bot back. And the only thing I needed to get that code to work is specifying the location of the camera relative to the base of the robot. So it's almost like you can add a component to the robot, add the software component, just tell you where that is relative to the rest of the robot, and it starts to work. The only problem is trying to figure out the orientation of the camera in Euler angles versus quaternion was more than I could do. I needed Rohan to do that for me. And it took him 4 tries, so it's like, because once you rotate one direction, the other one's the other way, and it's backward from what you think. So when I first did it, the camera was looking sideways out the robot, upside down and backwards. Any questions on that?
Matrices and quaternions are non-commutative.
Yep. Gimbal lock. So that's it.